So I've left you last time talking about the Arduino. What is the Arduino? Arduino is this beautiful board here. You have a power source, you have a USB for connecting with the computer, and you have a lot of different pins that you can use for different reasons. Most of the time when we start using the Arduino, we start using also breadboard. And breadboard are interesting for putting your electronics and connecting them to the Arduino without need of soldering anything. For making those design, I suggest you to use Tinkercad. We will use Tinkercad also for 3D design, and it's a really nice open and free access program. Said so, this time I will not use only slides for explaining the Arduino, but I can finally do hands-on. So let's check how it works. Okay, so this is what an Arduino looks like. You have a USB port, you have a power supply if you want to use a power supply. I wasn't entirely clear there. So this is the power supply and this is USB, that's true. But in this case, we are going to use the USB both for power and for communication. So we will always be using only the USB. And this is why it's important to remove it before making any connection. That's important. Power supply, USB, but in this case we are going to use only USB for power supply and communication. And you have a lot of different pins. Those one, no, my fat finger doesn't work. Better. So you have a lot of different pins on this side, 13 pins. Those one are digital pin, so they can be used both as input or output, and they are either on or off. Then you have the grounds, one ground here, and some of the pins have this tilde near them. This means that you can use not only for on or off, but also for give different amount of power. We will see it later. Then you have the power pins here, 5 and 3.3 volts. It means that they are giving power. So this one is not for powering the Arduino, but this one are for powering a sensor from the Arduino. You have the ground pins here and here, and you have the V-in. So this one is voltage in, this one is for powering the Arduino if you want to use, for example, an external battery. And you have a set of analog in. Those one are for sensors that are analog, so you cannot use only on or off, but you can use a lot of different sensors. So for example, if I'm measuring the temperature, or if I'm measuring the resistance, if I'm measuring light, I will use those one because the input will not be only 1 or 0, but it will be different numbers, and those one are the analog in. That's in principle the Arduino. The chip is this one. Then you have breadboards. How the breadboard works. This one is one breadboard. You will be given two different breadboards, 1 and 2. You will have different jumper cables. Those one are, for example, male. So it means that I have 2 pins at the end. And let's check how the breadboard works. The breadboard works in this direction, so everything that you put in this line will be connected. So for example, if I put this one here and this one here, this one here, it means that those two jumper wires now are connected. Those one are the standard breadboard and they are connected in this direction. On those breadboard you also have power, so those two lines are used for power and ground, and those one are connected instead in this direction. So again, if I'm putting this here and this one here, it means that those two are now connected. So when you have the big breadboard, you have those one for the pins and those one for the power supply. They are connected in this direction and they are connected in this direction. The small breadboard doesn't have the power and the ground, so everything is connected only in this direction. Remember, this is important. And historically, those are designed for chips. So if I put a chip in the middle, I want to have my connection here and here, so I can connect everything to the chip. Now let's make a simple design. So I'll pick up my Arduino. Is it so simple that I will use this one? And I will attach an LED. You should always remember that the LED is directional. So I have those two legs, one is shorter than the other, and the short one goes to the ground and the long one goes to the power. So I have my Arduino, I put my ground in, and this will be my ground. The ground, we say that it goes to the small one, so the small one goes here, and the long one, let's put it here. And this one goes to the LED. And for the LED, I say that I will use just digital output, and let's put it, for example, at number 8. So now my Arduino is connected to the LED and is connected to the pin 8. So pin 8, when I say open the pin 8, it will go to this pin here. This is connected to the LED. The LED will light, and this one goes back to the ground. This is how simple it is. Let's go back. Welcome back, and very important for the Arduino, when you're making all of those connections, remove the USB before you do all the connection. Then do all the connection on the breadboard on the Arduino and plug it back again. It's really hard to break an Arduino, but I've seen many students manage to break it. So please don't try it. It's not a huge problem, so it's not super expensive, it's quite cheap, but still, it's annoying. We have seen the hardware part, now we'll go for the software part. The software part, when you think about writing a software, you should always think about 4 different things. First, a flowchart, then an algorithm, then a program language, and then the machine language, but this one is going to be automatic. Flowchart is super important for understanding how the program will work at the end. There are plenty of different symbols. I want you at least to memorize 3 of them, which are the terminator, the process, and the decision. I will show you what I mean in the next slide. So these, you can see, they say it's a flowchart, but I have no idea how to read it. If I'm going for don't, should I choose make it bad, be afraid, or let me down? There is a decision there, but they don't tell me which decision I should take. It doesn't make any sense. So this looks like a flowchart. It's actually not a flowchart. Now let's check how a proper flowchart should be written. I will show you how a flowchart works using the first setup of a 3D printer. They use 3-axis system, so the X, the Y, and the Z. For moving the head, they need to know where the head is. So I need to point where the 0, 0, 0 on the 3-axis, where the origin of the axis is. And for doing this, they will use a sensor. I will show you in 1 minute how it works, and then we come back here. Let's go. So this is a standard FDM printer. It works just by moving the head around and printing on a bed plate. So I have 3 axes. This is my X axis, this is my Y axis, and if I move this knob here, you can see the bed moving. This also means that it needs to know where the 0 is, where the 0 for the Y, the 0 for the X, the 0 for the X, for the Y, and for the Z. And it does this using those sensors here. So this one is a flip sensor, a touch sensor. When it touches here, he knows that it's zeros. This one is the other one, and the third one is over here. Now, how it works when I home it. So auto home means that it's going to check where the zero are. So I press here and you will see start moving. It touched 1, it touched 2, and now it's moving the bed for touching the third switch. And it touched the third switch. It means that this one now is 0, this one now is 0, and the bed is also 0. Now we can start printing. Now, as you have seen, I have 3 different sensors for indicating where the 0 is. If I want to write a flowchart for this, I will write something like this. So start, I'm starting the motor, I start moving, then I tell the printer move axis Z, so it moves the head of the printer in the axis Z. Did you touch anything? So did you touch the switch? No, keep moving. Did you touch the switch? No, keep moving until it touched the switch. When it touched the switch, I give another command and say, okay, this is now position 0. And I will repeat this for all the 3 axes. After I finish all the 3 axes, I know, okay, this is now my origin of the 3D printing plate. So this one is 0, 0, 0. And I set it up. This is how we should write a proper flowchart. So you have a starting and you have an ending. You have commands that it's move the axe, and you have a decision. Decision is, did something happen or not? Same things for the 3D printing is about the temperature. So I have a nozzle and I have a temperature control, and I want to warm it up until 215 degrees. Did you reach 215 degrees? The thermistor says, okay, this is 50 degrees, not yet, keep heating until you reach 250. If you reach more than 250, then you stop the heating. Because you reach 250, yes, but it's too high, then the heating will stop. Now, moving from the flowchart to the algorithm, it's quite simple, because in this case, this decision making, so did you touch the switch, it's an if cycles. It's an if cycle. So if something happened, then do something else. And this is one of the classical if statements. You can use this one also for the other variables. If you touch the switch, then it's this. If you reach the temperature, then stop. If you don't reach the temperature, then keep heating. And there are many other constructions, for example, the for and while. So while you are doing this, do something else. For, do this for n times. Those are simple algorithms that you can write just in practically plain English. Flowchart and algorithms are really important when you do something extremely complex. This is something that we developed with the master student in our lab, and it was a PCR, so you have different temperature at different time. It looks quite complex, and actually it is quite complex. But if you start with a proper flowchart and then you write a proper algorithm, then everything becomes a little bit easier. Now I want to show you something super cool, and just a few seconds of the video, but I will put the video in the description here. Now, those robots, or at least most of those robots, don't have any sensor. Everything here is dictated by a flowchart and by an algorithm. And the funny thing of those robots, the things that I like most, is that if they don't have sensor, you need to guess which algorithm your opponent is using. If I know which algorithm is using, then I need to use a better algorithm. So if his algorithm is moving in circle, I need to move in the center and then try to push it out. If it's moving fast, I need to move faster. So it's the ability of detecting which algorithm my opponent is using. This is super fun. Some of them are also using sensor, and you can see how you can fake those sensors somehow. So for example, putting something there or flashing light. It's super nice from a technological point of view and from a robotic point of view. And most of this is done with a flowchart and with an algorithm. Then we go into the third part, that it's programming language. Arduino works in C#. It's not a very difficult programming language, and especially for Arduino it's pretty straightforward. The only things you need to keep in mind when you see this program is that you need first to declare the variables, so what are we going to use, and then there are two main parts in the program. One is the void setup and one is the loop. So the setup is going to be read only once, and here I put my constant, here I put which one is input, which one is output, here I put everything that should be stable, that will be constant over time. Then I have the loop, and this loop will be read in repeat. This one is the part that will be constantly going on as soon as you attach power supply to the Arduino. For giving an idea, we will just write a simple program that can turn on and off an LED, just for showing you the program, and I can show you directly on the computer. So let's see how the Arduino works. I open my Arduino, and this is the screen that you should be seeing. There is a void setup and there is a void loop. So as you remember, we have attached our LED to the pin 8. So the first thing that I want to declare is my integer number. It will be, I will call it LED, and this LED is on the pin number 8. All the lines that you write, you should close them with this, otherwise you will have a problem. Then I have my void setup here. This will be read only one, and here I need to specify that my pin number 8 is an output. So I will write pin mode, and I will write that my LED is an output. That's because I'm not using it as a sensor, so I will just give power to this LED, so it's only an output. Then I have my void loop. This will be read every single time, so this will be always read in loop by the Arduino. And here is where the program the program works. So here I can write digital write my LED, and my LED will be high. So this will mean give power to the LED. Another things that I can do here is putting a delay. And delay it's in milliseconds. So I can write delay 1000 milliseconds, and then I can turn off my LED. So I will go again for digital write LED, and this case will be low. This means power off the LED. And I give another second. My LED, sorry, I say that I will give another delay. 1000. Okay. And that's our problem. That's our program for turning on and off the sensor. And it's done compiling, so there are no errors. Let's see what happens if I forgot this one here. I try to verify, and now I have a problem. It says that this line doesn't make sense because he's reading this one and this one at the same time, so it doesn't have any interrupt. If I put this one back and I verify, it's fine. Another things that I want to show you, if you are in Arduino, you can go in you can go in File, Examples, and there are a lot of examples that you can find here. So for example, for the LED, if you go to Basic and Blink, these will be more or less the same things that we wrote here, but it's just using the built-in LED directly on the board. If you go for Basic and Fade, I want you to study this program and what it does. So again, I'm setting up my integers, I have my pin out, and then this is a program with an if statement. So study this one and think what this program is doing. And see you later. One interesting thing is this tiled. There are some pins with this tiled, and you can use those pins as an analog output. So if you have a digital output, the digital output can be either 1 or 0, so on or off. But if you're using one of those pins with this tiled, then you can use value between 0 and 255. That's because it's an 8-bit system and you have 256 possibilities. We will see this in a future lecture. So the difference between 0 and 255, it's the difference of pulse, it's called pulse width modulation. So I can turn on and off so fast that at the end the output will look like I'm using half of the voltage. So if I'm using 5 volts and I'm using a pulse width modulation of, let's say, 125, then I'm switching on and off that pin 50% of the time. So at the end the voltage will be around 2.5. The felt voltage will be 2.5. That's not real because the pin will still feel the 5 volt on and off, but the output will feel like 2.5 volts. This is important to note, especially if we are going to work with LED and you want to dim an LED. We will see later on how this works. Once you finish your program, you need to transform it in machine language. And this one, for example, is your program. And you have 2 buttons on the Arduino. One is to verify the code, so if everything is fine, and the other one is upload and compile. Once more, we are happy to be in this situation because then I can show you hands-on how the Arduino, how the programming for the Arduino works. Now, if you remember, this is the schematic that we did before. So we attached the LED at pin number 8, and this is our ground. When you use this, when you use LED, and you give 5 volts, you always want to use a resistor between the voltage in and your LED. So the resistor should be between your voltage in and your LED in this way. So you have your voltage in is coming here, is going to the resistor is going again here and through your LED. Now we have a resistor in between. Let's check on the programming side. On the programming side, we have written this program, so it's on the LED 8. My LED is my output, and then it will blink. So I say turn the LED on for 1 second, turn the LED off for 1 second. Hypothetically, your Arduino should be already recognized, so my computer already recognized the Arduino, and I don't know if on your computer you need to have some driver for checking, for connecting the Arduino. Once I've written this one, I can press verify, done compiling, and if I press now this one, it will upload to the Arduino. And now you can see the LED is blinking 1 second on and 1 second off. If we change something, for example, we can make half of the time, both high and low. I can upload, and now it's blinking faster. And now it's blinking faster. That's as easy as it goes. Now the other things, I show you that there are some special pins, and those pins you cannot use only high and low, but you can use any value from 0 to 255. This one naturally it's not anymore digital write, but it's analog. But we have a problem with the board because we are using a pin that it's not with a tilde, so I cannot use pulse width modulation with pin number 8. So let's change that one and we will see. I want to change my pin so that it's not on pin number 8 anymore, but let's say that we go for pin number 9 that has the tilde, so I can use the pulse width modulation. I first disconnect my USB. Always detach the USB before checking all the connections. I just change the pin here, so from 8 to 9, and I reconnect my USB ports. Now it's on again. In the program, naturally, now we need to change that we are not anymore using the pin number 9, and we are not using anymore digital write, because digital write means only high or low. I want to use now analog write. Analog write, now I can use any value between 0 and 255. So let's say what happens if I use an analog write here as well, analog write between 225 and 0. I will upload it. Upload, and now even if it's pin number 9, you can see the LED going on and off at the same, like before. Now the interesting things of this is that, for example, I can repeat this line and I can go for 200. I can repeat this one and go for 150, and then let's say 100, let's say 50 here, and then to 0. So this should be dimming, this should dim my LED. Let's upload it. And as you can see, now the LED every half second is dimming the light. So 255, 200, 150 until 0. So use the pulse width modulation when you want to change the voltage going to your LED or to your sensor, and use analog write for controlling the power that is going through. Now I showed you before the fade, and now we are going to see how this one works. It's already on number 9, so I can already upload it. And this is what this program does. You can see it's fading in and out. Now, again, try to read the program and check what it does. And that's it for this part. At home, we will try to use an Arduino for the detection of the SARS coronavirus too. That sounds weird, huh? We will see.